When working with acids and bases in a procedure, sometimes a specific molar concentration is needed of said acid or base. The molarity, symbolized by a large M of an acid or a base, is defined as the number of moles of solute, the solid acid or base dissolved in a solution of liquid, per 1 liter of solution. In this video, I'll be showing you how to make certain molar concentrations of acids and bases in the laboratory. For the liquid-liquid extraction procedure, which starts in video 1, a total of 120 milliliters of hydrochloric acid and 120 milliliters of sodium hydroxide is called for. For the HCl, the 120 milliliters of solution needs to have a molarity of 6m. For the NaOH, 60 milliliters of solution should have a molarity of 3m, and the other half should have a molarity of 6m. For now, we will focus on the 3m NaOH concentration. What this means is that there should be 3 moles of solute per 1 liter of solution of sodium hydroxide and 6 moles of solute per 1 liter of hydrochloric acid. Let's make our sodium hydroxide first. To do this, we must dissolve our solid NaOH into 120 milliliters of distilled water. To weigh all of this out, I will place a beaker onto a scale and press the 0 button to set the weight manually back to 0 grams. This allows me to add sodium hydroxide freely and count the weight of that without worrying about the weight of the beaker. To calculate how much we need to remember that the molar mass of NaOH is 40 grams per mole, and because there are 3 moles per liter, this means that there will be 120 grams per liter of solution. But since we are working in milliliters, we divide our milliliters by 1,000 to convert to liters, and multiply that by 120 grams. And then we find that we need 14.4 grams of solid sodium hydroxide per 120 milliliters of solution for 3 molar NaOH. Since I'm working with 2 different molar concentrations of NaOH, once I have used my 60 milliliters of my 3 molar solution, I will add more solid sodium hydroxide to increase the molarity of the remaining 60 milliliters. To double the molarity of this solution, since there already contains 7.2 grams of solid NaOH per 60 milliliters of water, 7.2 more grams of sodium hydroxide must be added. This is because 6 molar sodium hydroxide requires 6 moles per liter of solution, and 14.4 grams of sodium hydroxide is needed in total for 60 milliliters of water. Then, once I have 120 milliliters of water, I can add to it the solid sodium hydroxide. This reaction is exothermic, so not only does it release heat, do not hold it close to your face as you stir, as it is not safe to breathe. I would recommend using a stir bar on a heating mantle or stirring manually with a stir rod and leaving the beaker on the hood bench. At first, the solution will be white in color, but it will slowly clear up and the reaction will be completely done. Now, to make the hydrochloric acid, it's a much simpler process. There's a cabinet for acids next to the materials cabinet in the lab, and there's a section for hydrochloric acid entirely. Here, I have 12 molar hydrochloric acid, and to decrease the molarity by half, I just need to measure out half the total milliliters I need, which is 60, and then add that to 60 milliliters of water to make the molarity 6m. The benchmark rule is to never add water to acid, but you can add acid to water. I'm doing this through a funnel to make sure there isn't any spilling. Now that I can add that to the water, all I have to do is swirl the flask a little bit to mix, and it should be ready to use. That's all for making certain concentrations of acids and bases. Thanks for watching, and I'll see you in the next video.